Welcome to Tomorrow. We've got a killer show lined up for you today. Athena, what are you excited about?
Because United Launch Alliance has chosen its engine for its new Vulcan rocket, and it burns the same gas that your oven at home burns.
Awesome. Yeah. And what about you, Jade?
Well, we actually just got a whole bunch of unprecedented data from distant stars that uncovers more insights about our own sun. And the more we know about our own sun, well, hey, the more we know about space weather, the more we can mitigate a potential doomsday.
And I know how much sunscreen I need to put on. And we have Space Mike on the observation deck. What do you got for us, Space Mike?
Everyone, I am going to be talking with Chris Johnson from the Secure World Foundation about what you can do in space, what you can't do in space, what you might get in trouble for in space, and what needs to change so that everyone can go to space.
And then after that, we have your community comments. This is Tomorrow Orbit 11.38.
Good morning. How's everything up in the sky?
And thanks for sticking with us there. Now, we always like to start our shows with the coolest part of space, which is rocket launches. So, Athena, did we have any rocket launches this week?
We did. Okay, so we're going to start out with the Ariane 5 rocket. So, the European launch provider Arianespace had its 100th launch of the Ariane 5 rocket. It launched from the Guiana Space Center in Kuaizhou, French Guiana, on September 25th at 22:38 Coordinated Universal Time. Now, it launched two telecom satellites. One is the Horizons 3E satellite manufactured by Boeing, which separated from the rocket's upper stage 28 minutes after launch, followed by the Intelsat 38 Azer Space 2 from Space Systems L'Oreal 14 minutes later. And this was Arianespace's 6th mission of the year, and with it being the 100th Ariane 5 launch, that means it's time to make some room for the next generation of the Ariane rocket, which is the Ariane 6, which will begin launching in 2020. Which is really cool because both Ariane 5 and Ariane 6 will be launching coincidingly for 3 years until 2023. Now, these satellites are really cool. The Horizons 3E is considered to be the most advanced satellite by the Intelsat CEO Steven Spengler actually says, which is really cool because it's going to be able to give a lot of different details. So the next launch is going to be from China, and it had a launch of its Kuaizhou 1A rocket from the Jiuquan Satellite Launch Center. This was on Saturday morning at 4:13 Coordinated Universal Time. It launched the SentiSpace 1S1 small satellite, which will be in Earth-Sun synchronous orbit at an altitude of 700 kilometers. Now, right now, the use of the satellite is actually unknown, but assumptions being made it is going to be used for some type of Earth observations. Now, this launch vehicle that was used is really cool because it can be used with two different types of fairings. One is with a diameter of 1.2 meters and one with 1.4 meters, well, depending on its cargo. Now, the manufacturer of this space vehicle is X-Space Technology Co., which is actually a branch of China's Aerospace Science and Industry Corp. Oh man, now look at that launch. Isn't that just so beautiful? It has actually the capability of launching 200 kilogram payload into sun-synchronous orbit at 700 kilometers.
Woo! Good job, Athena! Nice work. That was your first time doing Launch Minute, right?
That was. I was shaking the entire time.
You did an amazing job. That was so cool.
That was splendid.
Thanks.
Oh my goodness. Now,
Delicious.
you talked about the Ariane 5 launch, which
Yes.
I was actually watching the webcast for. It was really, really cool and interesting webcast.
Yeah.
Why was that exciting for you?
Well, I'm really excited about this because Ariane 5 is actually going to be launching at the same time as the Ariane 6, which is going to be the next generation rocket. And they're going to be launching for about 3 years at the same time together. So 2020 to 2023. And I think the comparisons will be really cool to kind of see which clients will actually be wanting to launch on each vehicle.
Awesome.
Yeah.
And what does that bring our total launches for this year up to for the different countries?
So our total launches, as you guys can see here, that now makes China at 26 launches. And then you have the United States at 24 launches. Now you can see also Russia is at 10 launches, and then you have Japan, which is at 5. And then you got Europe at 5, India at 4, and New Zealand at 1. So
Yay, New
I'm
Zealand.
really excited about that. Yeah, definitely. I think China's still surpassing everyone right now, as you guys can see here.
Well, the Chinese launch that we just had then, that was kind of a surprise launch too. We didn't know that was happening this week.
Yeah.
We're kind of scrambling last minute to get video media for that too, right?
Yeah, I think it was last night around like 10 p.m. That was really cool. So that was really awesome, actually.
Yeah, I was excited
watch
about
it.
the payloads on that as well.
Yes, yeah, exactly. Yeah, the satellites and everything that's going into space.
Awesome.
So yeah.
Yeah, thanks so much.
Yeah, of course, of course.
So that was launches. And Jade, speaking of things that we put out into the solar system and things that we can get back from the solar system.
Ayo, good one.
What's going on?
Yes, so recently, some scientists from the New York University in Abu Dhabi actually were able to gather data from 40 stars similar to mass than our own sun, and get this, they were able to study something called differential rotation. Essentially,
Wait, what's differential rotation?
good question. It's
I
a
don't know
little
what
bit of
that
a
is.
mouthful, but it's basically the phenomenon where if you have a body that's not solid, essentially as it rotates, the equator will rotate at a different rate than another latitude, or especially its poles. Our own sun does this because it's made of a plasma. It's not just like a really hot rock, as we all know. It's it's a hot gas. And so as it rotates fast at the equator than mid-latitudes. And we thought our sun was kind of unique in this, but actually not quite. 13 of the 40 stars that were observed were actually shown to have differential rotations that are actually even more pronounced than our own sun.
But how do you, if it's so far away, then how can you even, like, okay, so tiny point of light, how
Yes.
can you measure that point of light is spinning?
I'm so glad you asked. So we actually use NASA's Kepler telescope, which we all know as a lovely exoplanet hunting telescope, but they actually use Kepler data to be able to look at differential rotation. And the way that it did this was it studied something called, similar to the Doppler effect, what it does is it actually measures waves that travel throughout the stars, and that causes the ever slightest change in brightness. So as you know, when we look for exoplanets, we look for a slight dip in brightness when it transits its star. Essentially, we did that with waves that are propagating within the star itself.
Wow.
And yeah, absolutely, wow. And this is really cool because our own sun, to give you an idea, rotates about 11% faster at the equator than it does mid-latitude. So it takes about 25 days for one rotation at the equator versus 31 days at the mid-latitude, and then it's actually even more pronounced when you get to the poles. However, they were studying stars that were up to 2.5 times faster at rotation in their equators than their poles. So basically imagine this. Imagine you live at the equator on Earth, and essentially you would experience 2 sunrises and 2 sunsets a day.
Ooh.
Yes. And so to kind of illustrate what differential rotation looks like, Dada just put up a photo on the screen here. And as you can see, it's more pronounced at the equator than the latitudes going up or down. And I'm glad you mentioned how we were able to make such detailed observations. The prior method was we actually used star spots at different latitudes, or Doppler imaging.
Star spots because they're not on the sun, so you
Get
can't
it?
call them sunspots.
Yeah, you know? Our sun is our sun. It is special, and it gets that special word. Or Doppler imaging to track the migration of these, the latitude of these different magnetic features, including sunspots, or star spots, as I should say. But as you could probably imagine, most stars are a little bit too far away to really discern these types of surface features with any clear resolution. So scientists use a method called astroseismology, which is as exciting as it sounds. And again, like I said, looked at how waves travel through stars, causing very tiny dips in the star's brightness, but enough to be able to surmise those different rates.
Well, there's a really good question in the chat room actually from Strati.
Yeah.
So they want to know, like, you know, we know that it's spinning differently.
Yes.
But does this depend on the mass of the star? Is it temperature dependent, or is it something else that's happening?
So that's a really good question. So a lot of differential rotation actually relates back to convection within a star. So convection is basically the rising and cooling of materials within the star itself. So the fact that these stars do have such a more pronounced rate of rotation, I'm not entirely sure that they've identified a singular mechanism as to why it's so much more pronounced than our own sun, but certainly it would have to do with about the stellar dynamics itself, essentially.
Awesome. Cool. And now that we know that they're spinning, do we know if it affects like the light or the radiation coming out of that
Now,
star?
this is the exciting part, and this is what I mentioned when we first got to say hi to y'all. Essentially, the relationship between differential rotation and a star's magnetic field are pretty intimately intertwined. So let's imagine our sun. It's this cute ball of gas in the sky. And like I said, it's rotating at different rates. So what that means is if you can imagine a bunch of little magnetic field lines and they're getting all twisted into all these different contortions simply because there's different rotations and it's not just one cohesive, neat pattern. Imagine a rubber band constantly getting stretched and twisted. What's going to happen to the rubber band? It's going to snap.
Yeah.
It's going to snap
you in the face.
and it's going to shoot through the
Yeah.
surface of the sun, and that's how we get things like sunspots. That's how we get, coronal mass ejections. It's how we get all sorts of sometimes neat and sometimes violent things that happen on the surface of the sun. And solar weather has a very intimate impact on things that can happen on our own planet, including messing with satellites, as well as even affecting our electrical grids on the surface here.
What's the worst thing that's happened from a solar event? Like, how has it damaged us?
Well, I mean, I think, what was it? Historically, wasn't it not too long ago that there was a recent event that happened that it messed with the GPS of satellites and then even the electrical grid? There was like a blackout. I can't remember the exact time and place, but there have been instances where there were towns or people affected, and because we're so dependent on electrical grids nowadays, and I don't know about you, but I'm pretty darn dependent on my GPS signal.
Yeah, me
There
too.
are so many things on the
too.
line here, and so the more we know about these distant stars, the more we can figure out about our own sun, and again, better understand the dynamics within, and potentially mitigate any future quote-unquote scary times.
Awesome. Speaking about learning about our own sun, is there any way that people at home can safely look at sunspots or observe the sun?
I will say this, public service announcement, never stare directly at the sun, despite what you may have heard on the news. Do not stare at the sun. But they do make special solar sunglasses, which are actually really cool, and they basically have a filter on them so that you can safely look at the sun because it decreases the sun's brightness quite a bit. Oh, look at that! Dud is actually modeling them. Oh, so lovely.
That was amazing.
Oh, that was fleeting. I hope you got a close-up of that. Or if you have a telescope, you can actually put something called a hydrogen alpha filter on that telescope. And again, what that does is it filters away over 99% of the total brightness of the sun, and you can actually discern surface features. So if there's a sunspot that's particularly prominent that day, you too can see it with your own eyes. Without going blind, which is cool.
Yeah, nobody wants to go
love
blind.
each
Safety
alpha
first.
filters.
It's,
Not today.
Rule one of the show.
Don't die and don't go blind.
Thanks, Jade.
Anytime.
We're going to switch gears a little bit here, and Athena, we learned some pretty cool information about, a rocket that is going to be using the same stuff we use in our kitchen.
Yes, so United Launch Alliance has a new rocket, and it's called the Vulcan rocket. I had to choose this piece because last week I was talking about Vulcan.
Is this the Vulcan thing? Oh.
This is, you were going to do the hand. So this is actually an artist rendition of what the Vulcan rocket is going to look like during liftoff. So it's United Launch Alliance's newest rocket, and they actually just announced that they have decided upon which engine they're going to use for it. So they're going to be using Blue Origin's BE4 engines, which is...
What engine are they using at the moment?
So they're using the RD-180 engines for a lot of their launch vehicles, which are cool. They're fine. They actually produce quite a lot of thrust. They're from Russia, and they actually burn kerosene and oxygen. So that's cool and everything. But I mean, look at this. This is I just love this image so much. This is when it was out on display. But I think what I like so much about this engine is that it actually is powered by liquefied natural gas and liquid oxygen. So this is why earlier I was saying I'm so excited because it's the same gas that is used in your ovens at home. So talk about going all natural and this movement forward and trying to really produce what you can that's good for the environment. So I like that it's
thrust do these guys produce?
Oh man, a lot of thrust. So one of these can produce 550,000 pounds of thrust, and this is during
cool.
the hot fire test, which. Oh my gosh,
It looks
it's
so
just
pretty.
It's
oh
gorgeous.
My goodness, it's so powerful.
So powerful. So that's really, really cool. And actually at liftoff, there's going to be two of these engines that are going to be combined for this launch vehicle, the Vulcan launch vehicle. And together combined, they're going to produce 3.8 million pounds of thrust at liftoff. So that's going to be used, this is a picture right here you can see, it's going to be used in the first stage of the rocket. So it's also going to have additional strap-on boosters on the side, which are going to be solid fuel boosters by Northrop Grumman. So really depending on kind of like what the payload and the weight and trajectory is, will depend on how many of those strap-on boosters you actually will need. So then that first stage is going to separate. And they're actually looking to make it reusable in a sense.
Wait, a next generation heavy lift rocket that's going to be reusable? Who'd have thought? Sorry. No, that came out way more snarky than I meant to. I'm so sorry.
Someone didn't have their
enough coffee. But hang on. Let's get into the nitty-gritty details here. How is the Vulcan going to be achieving, reusability?
Yeah, so their goals is to have, I didn't read too much on the specifics, but the goal is to have that first stage try and be actually reused, to have that be salvaged, and then be able to reuse it for future missions. So as you guys saw in the diagram, the second stage is then what's going to be bringing, obviously, the payload into space, and then that first stage are looking to actually have it land, potentially maybe do a vertical landing. I know that the New Glenn, which is part of Blue Origin, New Glenn rocket is looking to do a vertical landing of their first stage. But with United Launch Alliance and their Vulcan rocket, they're looking to do the same. I mean, reusability is definitely important. It's the trend right now. Yeah.
So these engines are getting used not just on the ULA Vulcan rocket, but on Blue Origin as well?
Yeah, so Blue Origin, I mean, since they're the manufacturers of their engine itself, the BE-4 engine, they are looking to also use it on their New Glenn rocket as well. So that's going to be obviously really, really cool. And they're expecting, obviously, to have a pretty heavy payload on that as well. So having that 3.8 million pounds of thrust at liftoff is extremely important. So yeah, they're looking to use this engine for multiple uses, and again, I just love that it's powered by natural gas, like liquefied natural gas.
Awesome. So we have Destructor 1701 in the chat room talking about reuse. The plan is not first stage reuse, engine block ejection and capture under parachute by a helicopter. Oh my
wow!
goodness.
Thank you, Destructor 1701.
That's very.
So I guess different
Mission
companies
Impossible.
are pursuing reusability.
Yeah, was that for the New Glenn or was that for the Vulcan?
That's for Vulcan.
For Vulcan, okay, for Vulcan, yeah. So yeah, it's really cool, and yeah, like you said, different uses for different companies, different rockets. So obviously New Glenn's looking to do that vertical landing, and Vulcan's looking to do the parachute.
And liquid natural gas is predominantly methane, right? Mm-hmm. So do you think in the future Mars? Yes, exactly what I was getting at.
Yeah, yeah, exactly. So it's really important right now that we start really incorporating using liquid natural gas, methane-based, because if you plan on obviously making our journey over to Mars, you're going to want to be able to find a way to repurpose what you can find on Mars and use it as fuel, because when you get there, you're going to be all out of fuel. So it's good that they're able to incorporate that. It's extremely important.
We're going with the rockets of the future.
Yes.
And speaking of Mars and the future, Jade, tell us a little bit about what's going on with Mars, and that was a totally winged segue.
That felt right. All right. So, Lisa, so there's been a very, very interesting new look at old data that has to do with Mars's two adorable little moons, those little potatoes we know and love, Phobos and Deimos. And this comes from the Journal of Geophysical Research Planets. And essentially, this is data that we were able to get from NASA's Mars Global Surveyor. And get this, we may have an alternative explanation as to how these moons formed, where they came from, why they are there, and everything else you could potentially want to know about this adorable little thing. And
how do we think the moons got there at the moment?
Well, good question. So based on what we can observe right now, it's pretty popular to believe that these were captured asteroids. The reason we think that is because the surface of these moons is quite a bit darker than Mars itself. That's due to a presence of carbon, and also because it's so tiny compared to Mars, it basically has all of the evidence of being an object that was captured in the past. And actually, if you were to look at these moons in visible and near infrared, they do look like D-class asteroids.
Cool.
However, there is one big piece of controversy that always surrounded Mars's moons being captured objects, and that is, yes, They are hollow, full of delicious chocolatey nougat. I'm kidding, that would
Yes,
be
I
wonderful. But actually, less exciting, their orbits don't make sense. So if you were to ask an orbital dynamicist researcher, they would say, well, if you trace back the orbits of Phobos's motion over time, the features of the orbit do not allow for it to have being captured. And that's actually pretty interesting, because what that means is one of the most popular theories about the Martian moons has a huge hole in it. And so looking at this data from the Mars Global Surveyor, which was measured using the tool, the thermal emission spectrometer, I just had to say that because I just think it sounds cool. Basically, they studied the heat signature of Phobos and Deimos. And although they are quite cold objects, using mid-infrared lengths, compositionally, these moons look more composed of basalt than anything else.
Hang on, what else in the
Wow.
solar system is made from basalt?
Us, our surface, our moon, yes. So basalt is just volcanic rock. So if you were to study the moon, that's what you have on the surface of the moon. And that's how we surmise that our own moon was a part of Earth at one point, because it's compositionally very similar to our crust. And so because it looks a lot like basalt, what they did was they compared this data with various samples we already have here on Earth, including terrestrial rocks, so rocks you'd find in your backyard, as well as a meteorite from an asteroid believed to be similar to the ones that Phobos and Deimos may have been a part of at one point. And what they did was they found that the data, if you compare it, actually more closely resembles the terrestrial basaltic rock versus the asteroid, or the meteorite we got from that asteroid. And so what this means is if you were to connect the dots, that means the moons may have been a product of an ancient impact within Mars's first billion years of life, which is fascinating because that's exactly how we think our moon may have formed, with Theia bonking into our Earth, and then voila, you have a moon.
So are they just made just from Mars rock or just from the impactor?
Good question. The answer is it's sort of a love child. We don't think it's 100% one thing or the other. It would be more so a fusion, a mixture of these materials, and what you have is a beautiful baby potato that orbits you day in and day out.
Speaking of potatoes, why are we so interested in Phobos and its potatoey shape?
Well, personally, I think it's fascinating because you have these two conflicting theories that are just, directly, you kind of fight each other, but both are just as valid in terms of the evidence they have going for them. And the more we know about moons, the more we know about the moons of Mars, the more we can know about moons in more distant parts of our solar system or moons around other exoplanets. And if you want to bring it back down to the, looking for life argument, moons are amazing opportunities to study the potential for life outside of our very own planet. So the more we know about it, the more we can potentially explore these worlds for a critter or two.
You've convinced me I want to go to Phobos now.
I mean,
are there any missions that are going to go there and
absolutely
go to Phobos?
If you've been tuning in, you might know that we actually now have the capabilities to have return missions. So we actually have, for instance, Hayabusa 2 and OSIRIS-REx, we have capabilities to bring actual physical, tangible samples back to the surface of the planet to study. In fact, JAXA, the Japanese aerospace agency, is developing the Martian Moons Exploration Mission. It'll launch in the mid-2020s, but it's essentially going to travel to a Martian moon and bring us back a little piece.
I'm so excited about it. Can you
I hope
imagine?
there's chocolate nougat.
We could make a necklace like your
I
necklace,
was going to say,
but out of
search
Phobos.
Etsy. I'm pretty sure you're going to see
Etsy,
some
yeah.
Martian moon jewelry
I'm so
Oh,
into
yeah.
that.
for $1 million.
All right.
wonder how much she'll bring back.
Speaking of things you could buy with your money, if you
Cool.
would like to support the shows of tomorrow, I'd love to give a very huge shout out to all the people that already do. So we have our lovely citizens. So thank you very much. We could not do this show without your contributions. Specifically, our Escape Velocity citizens. These people contribute $10 or more per episode to this show and make this show happen. Thank you, thank you, thank you so much. If you'd also like to contribute to the shows of tomorrow, head on over to patreon.com/TMRO. All right, we're going to take a quick break, and when we come back, we're going to have Space Mike interviewing Chris Johnson. This is the future, this is tomorrow.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
And welcome back. Thank you for sticking with us. Real quick, I wanted to introduce you to Chris Johnson. He is a space law advisor for the Secure World Foundation. He's also an adjunct professor of law at Georgetown University and has worked with the International Space University as well as UNUSA, the United Nations Office of Outer Space Affairs. So we're going to be talking a lot today about space policies, space laws, what you can do, what you can't do in space, and how we are trying to enable the world to have access to space. So again, thank you very much for joining us and talking with us today. First off, I wanted to ask you about the Secure World Foundation and what it is that you do for them and their mission and how they're trying to enable space access.
Certainly. So Secure World Foundation is a private operating foundation. It's an NGO, non-governmental organization. And you know, it's a very small NGO, and honestly, there's hardly any NGOs that are specific to space activities. And our focus is on peaceful uses of outer space, international cooperation for outer space, and the continuing use of outer space for human and environmental security here on Earth. So it's tying what, you know, all the things that we do in outer space and our capabilities with space, how they tie back to on Earth to benefit people on Earth. And it's, preventing conflict in space. So what you do as an NGO, you're a very small player. You're not a state, you're not a space agency, you're not a government, you're not an international organization like the United Nations. So you do what you can as an NGO. And essentially that's getting people to talk to each other, different stakeholders, users of the space domain, to talk to each other, understand the issues that they face, that they all face, and getting them to empathize with one another. So it's, facilitating conversations and being a good offices and someone who speaks for civil society. So if you have a meeting where there's governments and space agencies and the commercial industry, well, who speaks on behalf of everyone else? Civil society, the rest of the world who has a stake in outer space. So that's what an NGO is tasked to do in the international political system, and that's what we try and do for space. Wow, that's really inspiring. It's tough work. Yeah, I'm sure it is. Let's talk a little bit about that because from what I've seen, there's a lot of, especially third world countries that are working on university projects with CubeSats or even having higher ambitions to create their own space agencies. And what sort of difficulties and problems have you faced trying to help some of those folks? And what does it take to even organize to create a dialogue to get the right people speaking to each other? Well, all right, I'll tackle the second question first. The dialogue to get the right people to talk to each other, I'll put it like this. Let's look at the small satellite revolution. The small satellites, that's often people's first activity in space. It's the, small companies, startup companies, universities that are learning everything that they want to do in space, but learning it on like a smaller platforms, small satellites first. If you're a startup company, you want to get to space, you want to prove your concept, you want to do it quickly, you don't want paperwork, you don't want long wait times, you don't want costs like insurance to slow you down. Because every day that you're not doing something in space, you're burning money. Time is, this is essential to be a success and show your success as a startup company. And then now let's look at the regulatory side of it. Let's look at the International Telecommunications Union, the ITU. For the ITU purposes, there's only two types of satellites: geostationary satellites and non-geostationary satellites. And whether your satellite is going to be very small or whether it's a gigantic, pristine satellite the size of a bus, the filing fees, the wait times to get your frequency coordinated can be a number of years. So there's a huge mismatch in terms of the regulations that are in place, because they were put in place for traditional space, and the interest of people who want to get to space and do it quickly. And both of them think that they're doing the right thing. They both think that they're good guys, and they are good guys. They both think that their approach to space is the approach that we need in the future. So you have to get those folks to talk to each other. You have to get the small satellite community to see the necessity and the utility of international law and international coordination and cooperation for the use of frequencies and useful orbits. So they have to talk to the ITU and see the goals of what the ITU is trying to do. So you have to somehow help those meetings happen, get those people chatting with each other and working with each other so that they can all do what they want to do in space, and they can do it in a sustainable fashion. And that's really the key, the sustainable fashion. So I use one example of small satellites and the telecommunications union. You can draw so many other parallels, the commercial space and what the regulators are tasked with doing. And the linchpin of it is Article 6 of the Outer Space Treaty. States are responsible for our national activities. So there's what we call commercial space, but in the context of international law, all activities are national activities. So whatever SpaceX does in space, the US government is quote unquote on the hook for that. They're internationally responsible for everything that private company does. And that's the way that space law is set up. Anything is a national activity. So you have to work with the regulators. You have to work with the government, have to get them talking. Governments and the US government want to allow these things, but they're not going to bear all the risk.
Sure.
There has to be some oversight and some regulation.
What are some of the biggest difficulties that you've come across? Do you come across any sort of us versus them mentality, or is it really just a lot of the legalities?
I think there is us versus them mentality, not so much in commercial space and what the regulators want. The approach in DC and the approach from the U.S. regulators is they want to see space activities happen. They want to give a license. They want to see new non-traditional emerging activities. They want to see satellite servicing happen. They want to see manufacturing in space happen. They want to see next generation space activities. Use of resources in space, commercial space stations. They want to see it happen, but they have to make sure that it's going to comply with what the U.S. has obligated itself to do under international law. So there isn't that us and them mentality in terms of commercial space, but once we step over to the more difficult geopolitical realm of the security aspects of space and geopolitical tensions, then I don't want to say it's us versus them, but it's a uncertain system where you can infer or you can have a curious posture towards activities of other states.
So hypothetically speaking, let's say that you are in a country that doesn't have its own spaceflight capabilities. Let's say that you are in South Africa. Let's just pick that out. And you have a CubeSat project that you're wanting to build. What can you do and what can't you do in order to try to get that flown?
Okay. So there's so many different ways that we could take a question like that. I like the last aspect of it. What can you do and what can't you do? Because I want to plug international space law, and I want to get people aware of what international space law is and the content of international space law. And I'll explain it like this. You can go to the United Nations Office for Outer Space Affairs website and get the texts for free, download the PDF of what the space treaties say. The Outer Space Treaty of 1967, the 1968 Astronaut Rescue and Return Agreement, the 1972 Liability Convention, the 1975 Registration Convention, 1979 Moon Agreement, and then succeeding General Assembly principles and declarations. And, it won't take you long to read these core treaties. And what treaties do is they establish rights. On the one hand, you have the right to explore and use outer space, and those rights are balanced against obligations. And those obligations are, you must register your space object with the United Nations. And there's positive obligations. You must go and do this. If something lands on your territory that was launched from another state, you have to return it to that state. You have to offer it to be returned. And those obligations can also be negative obligations in terms of you cannot do that thing. You cannot, appropriate places on the moon as part of your national territory. You cannot place weapons of mass destruction or nuclear weapons into Earth orbit or station them on celestial bodies. That's a negative prohibition. So what space law does is it balances rights and obligations. And, but the key to understanding all of it is it's very limited in scope. There's a lot of gray areas and unanswered questions in space law. The Outer Space Treaty is a treaty on general principles, and it was intended to be a treaty on general principles. So if you look to the treaty and say, where does it say I'm allowed to put up a commercial space station? Is it either positively permitted or is it explicitly prohibited? there is no answer on it. It doesn't mention commercial space stations, just like it doesn't mention manufacturing in space, use of space resources, satellite servicing, deorbiting, space debris, removing space debris. It is silent on all of those questions. It's a limited regime of general principles. So once you understand that, you then have to say, okay, well, the law isn't clear, either giving a green light of go ahead or a red light of no, you can't do that. It's what would we like to do in space, and is there a prohibition on doing that in space? And so that's where it gets tricky for developing nations and states that are not space accessing. They don't have their own, launch capacity, launch capability. They're encouraged to do international cooperation by space law. And so they're going to use space assets for their national goals, whether that's remote sensing and land management or GPS, PNT type of applications, border verification, et cetera, et cetera. And then slowly from there, they build up their capacities and use of space. And that's encouraged.
Related to a third world country and also who's responsible, there's a question from our chat room from Jarnis, who is commenting on Twitch, that asks, what about a company, for example, Brazil using a SpaceX rocket? Who's responsible for that? Would it be Brazil or the United States? And I think you kind of answered that already. Since it's SpaceX launching it, that would be the United States who's responsible. True.
So it's, other people get kind of, they get bored or they get upset if you give them a kind of a legalistic answer or you encourage them to go actually read what the law says. But it's pretty clear in the Liability Convention and the Registration Convention what a launching state is. And there's 4 categories of launching states: the state which launches, which procures the launch, or from whose territory or facility a space object is launched. So you could say that, if it's a SpaceX rocket, the U.S. is definitely a launching state. But if the Brazilian government procures that launch, they could quite easily be also considered a launching state. Or if it's a company that's headquartered in Brazil, it's easy to see, and a strong argument can be made that Brazil is also the launching state. So launching state, that's who would be responsible for any physical damage in space or on the surface of the Earth or in the air. And that's for physical damage. So, both the U.S. and Brazil will be interested in supervising and authorizing that activity to make sure it complies with international law and their national approaches. It could be the responsibility of both, joint and several liability under space law.
Interesting. There's another question.
Is that a long legalistic answer? I'm sorry.
No. That's okay. That's okay. That's why we're here, to kind of translate all this legalese, right?
Okay.
There's another question from our chat room that is kind of related to that, especially when it talks about debris. This is from Destructor1701 in our chat room that asks, space debris cleanup is a hot topic lately. How do you see the legalities of that panning out? Who can touch what, and when does an asset become junk from a legal standpoint? Law of the sea? Question mark.
This is a great question. A series of questions from Destructor 1701. Thank you. So space debris is not essentially addressed explicitly in the Outer Space Treaty or any sources of international space law. It's we have a definition of space object, and if the space debris. It's all right. So here are things that are unclear under space law. Can you remove your own space debris? Likely, yes. But can you remove someone else's, another state's space debris? Like I said, neither the green light of go ahead nor the red light of no, you can't. We want to be able to do these things. Governments want to allow these things to happen. So like the technology may be sound. There may be a business case for it. There is a business case for it, but guess what? If you have the technology and the capability to remove debris, you have also the technology to remove someone else's satellites. You have the technology. You have a satellite killer. You can take someone else's space infrastructure offline. And because of that, if you are in the guise of putting up a space debris remediation mission, states may go, well, that's what they say they're doing, but what are they really going to be doing with these space assets? So it's unclear what, it will raise tension with that. Right at the end, he writes, law of the sea, is there a parallel? There is a parallel in some senses, in some economic senses, and space law developed in a way that is, kind of modeled after law of the sea. They're different domains with different special laws, but they're both areas outside of states' national territory where states extend their jurisdictional powers into those, what we call the commons. Space is not a global commons, but economically speaking, it is a commons, in the sense that we all share it and have access, we all can share it and have access to it. And so there are some parallels with law of the sea, and we can certainly look there. There's salvage law in maritime law, but there isn't in space law. And that's one of the things that we need to develop. And whether it's going to develop through a new international treaty or, actions by states that permit space debris remediation, we want to make these things happen. And the clock is ticking. We want to start removing space debris as soon as possible, especially the large stuff that can cause more debris, or the small stuff that can interfere with our assets and capabilities, especially in the low Earth orbit and medium Earth orbit.
Very interesting. And that kind of brings me to how far it goes. This is a question from Lur in our chat room, who asks, does space law extend beyond lunar orbit?
Yes, definitely. So we don't know. There's no lower delimitation of where outer space begins and where airspace ends. But essentially, space law, and this is one of the interesting things that got me into it, just the scope of it, the ambition of what space law seeks to address and regulate. Regulates humans' activity in outer space, but space law governs launches on the ground, space activities on the ground, use of space for remote sensing looking at the ground, but then it also governs, it's everything from what happens in low Earth orbit and beyond, including what happens on celestial bodies, the use of frequencies, the use of orbits. And there's no hard binding international law of planetary protection principles, but there are COSPAR guidelines for planetary protection principles. So that the scope of space law is essentially, unlimited.
Very interesting. And this brings me to another interesting question from Destructor 1701, which asks, in planning laws, you must take into account the future context of that law as much as you can predict. What sort of strange considerations have you found yourself taking when thinking about the space industry and culture of the future?
So, the first thing that pops into my mind from that is, asteroid threat mitigation. If there are asteroids which would threaten the Earth, threaten destruction on the Earth, standing up missions to deal with that debris or deal with that asteroid threat. The technology to do that is essentially, like nuclear weapon technology, even though it would not be a weapon in the traditional definition of how we consider weapons in international law, especially the law of armed conflict, whereas a weapon is targeted towards a foreign enemy with military purposes. This would be merely a repurposed nuclear weapon that would be a nuclear device to destroy an asteroid headed towards the Earth. But there are these difficult issues. Like I said, Article 4 of the Outer Space Treaty says that states are prohibited from placing nuclear weapons or other weapons of mass destruction into Earth orbit or beyond. So can you lawfully use a nuclear device to destroy an asteroid? It's an uncertain question.
Makes
Hopefully,
me wonder,
but again, we don't have a clear answer on that.
Makes me wonder if that situation were to happen, if maybe the UN could be the authority that's actually launching the nuclear warhead. And I don't know if that'd be a way around the law, or if that would be something that at least the signatories, excuse me, I can't even speak right now, would agree to, is if the UN was the one coordinating that effort.
Well, if you want to get into it, there is two bodies that work out of the United Nations Office for Outer Space Affairs. One is the International Asteroid Warning Network, IOWN, and they're tasked with detecting the asteroid threat towards the Earth. They're one working group and one working body, the IOWN. And then once, if a mission needed to be stood up to face this asteroid threat, it's the Space Mission Planning Analysis Group, same page. So Same Page also works out of the Office for Outer Space Affairs, or USA is the secretariat to Same Page, and that would be the international body that coordinates a mission to destroy asteroids that threaten the Earth.
Very interesting. Very interesting. I have a couple more questions from our chat room that I'd like to ask. This one comes from Hanny's Vorwerp off of Twitch, and they ask, what old laws are holding back the growth of a 21st century space economy?
Oh, this is a great question. So, the law works on precedents, and we'd like to not invent new things, but look to what has already been done, what people already use, and what can be proven to work. So this is why, wills and trusts, writing up a will, you look to what's worked for, the last 100 years. Property law is descendant from Old English law, American law. The common law system comes from the English common law system of judge-made law in addition to what is written in statutes. And, our ideas of property law actually stem from the Romans. So we have lots of Latin terms in national law and lots of Latin terms in international law. So when we discuss, the use of space resources, we can be using Latin phrases that were used in the Justinian Code from the 4th century AD of res communis omnium, res nullius, of areas that things or areas that are able to be appropriated or not able to be appropriated, or not able to be appropriated, but we can use them for commercial purposes. That's res omnius. That's res communis commercicum. So, we're using Latin phrases from 1,500 years ago and applying them to the space domain in a way that's analogous, and we use them as general principles of international law. Of these general principles that could be hundreds or over 1,000 years old, and because space law is a branch of international law, and general principles of international law apply to space, then we can get dragged down by using Latin phrases for the space domain.
Sure.
I think it's not something that we should be doing, but that's what happens.
That's why I call it Legalese, and that's why we need folks like you to help us figure out what the true purpose is behind a lot of these policies. I have a few more questions that are related. First, I wanted to ask, Tickle Stuff in the chat room asks, what happens when satellites are launched unlicensed? For example, the two startup satellites that were launched on an ISRO rocket without U.S. government clearance. And then I have a follow-up question to that, too.
So, I wanted to add to the previous question. We are bound by laws, but laws are supposed to serve people. So whatever the laws are, we should be as the current generation, not bound by what the past has always done. We can make new and better laws. So that's always the overriding goal, is that the rationale, the deep rationale behind law is that it can order life. It put guidelines for life to make things better, to make the living situations better. So the laws can change to make a better future. So this question has to deal with the Swarm satellite launch that the company did not do their frequency coordination with the FCC. They launched anyway. This was kind of unprecedented, and the first time that such an activity had happened, where they didn't get their frequency coordination license from the FCC. They and then just decided to launch anyway, and to don't worry about it. We'll turn our transponders on after it's already in space. So that's not a good move. It's not a good look. It will not be good for that company in the future. The next time they approach any regulatory body for a license, it's not good for their reputation. It's not good for people who want to invest in them. VCs don't want to invest in companies that take shortcuts or try and short circuit the system or do end run around the law. The U.S. government would be a launching state for that. They'd be a responsible state. I've spoken both with folks in the U.S. government and with the folks from Indian space lawyers, and who will admit that India is also, of course, a launching state and probably a responsible state for that activity. The good thing is I think that those satellites are in a low orbit, and so they'll burn up and re-enter the atmosphere and completely burn up. Not in 25 years' time, but in a shorter amount of time.
Yeah. In fact, that launch was a while ago. They might already have burned up, from all I know. But to kind of on this subject, To Wicked from our chat room asks, recent history has shown that treaty violations don't see much action from the other members. Do you think it would really be any different hundreds of thousands kilometers away from Earth? And something that I kind of, to add on to that, who is responsible for kind of following up? If someone does break the law, how are they going to be punished for that? And would it be other members' responsibility to kind of, my mind goes into like bigger army diplomacy type of thing. How do we make sure that these treaties are held in place, and if people violate them, who is responsible for penalizing them?
Yeah, great question. And this gets to the heart of international law as its difference from national law. I saw a good tweet the other day of the phrase that international law is a system of peer pressure, of you can try and force other states to comply with what you've agreed the law is. There's no set in stone enforcement mechanism for lots of laws. There can be adjudication through the International Court of Justice when states agree to it. There can be adjudication in bodies like that. But if a state violates international space law, other states that feel affected by it and aggrieved by that action are no doubt working with that state in other areas besides space activities. They're working with that state in the economic realm, in the security realm. There's consular and relations that they have with that state. And so there's basically a whole basket of options that you can kind of pressure that state to cease violating the law and begin complying with the law and promise to not violate the law again. There's a whole suite of options, and the one that U.S. government likes to use is sanctions and affecting their trade and their economy. You hit them in the pocket, and that's really where you can have some type of pressure on those states. And even though states do violate international law, they always say, well, we're not violating the law. The law exists. We're bound by it, but there's some special exception where we're not bound by it. So even in the breach of the law, when they get called out, they still say, they don't say the law doesn't exist. They say right now we're not bound by it. There's some extenuating circumstances behind it. But yeah, that's the trick. And we'll admit that that's the international system is based on kind of peer pressure and good relations. And if you're known to be a known persistent violator of international law, it kind of gives you a pariah status where states know about your bad your reputation and don't really want to enter into new treaties or new arrangements with you because you can't really be trusted by any document that you sign.
Interesting. Well, this kind of brings up another point that makes me wonder about transparency and whether or not they should be communicating with each other. This comes from a question from Neuropilot in our chat room, who asks, I thought that there was a de facto agreement to notify the United States, Russia, and China of launches to avoid misunderstandings of possible ICBM launch. Could something similar work for certain activities that are not settled in the treaty?
Yeah, definitely. So we definitely do have those security assurances and transparency assurances between states. That's what we try to do with international law, is say, we will let you know. We don't want to have any type of, the phrase is misperceptions, misunderstandings, and anything that could lead to tensions rising between states by what is essentially innocuous activity. So that's what we need for space also, and we need these types of transparency activities. So getting back to, an emerging activity in space is satellite servicing. We want to go up to satellites that are non-functioning or misfunctioning or in the wrong orbit and move them out of orbit, put them in the right orbit, move them to a graveyard orbit, deorbit them, or service them by refueling them and repairing them. But the technology to use that can be kind of suspicious looking to other states.
Could be an interceptor.
If you have a satellite that has scissors and snippers and the ability to interact and perform those rendezvous proximity operations on satellites, that can look a bit threatening to states that, may not believe that you're going to do what you've said you're going to do. So the only way to solve that is through transparency and by letting states know, this is where we're going to go. This is exactly what we're going to do. And do it in an open and transparent fashion.
Wow. So what's next then? How can different member states that are already part of the treaty and people who want to participate in spaceflight in whatever capacity, how can we get to a point where we're more transparent with each other and the process of getting through the red tape and being authorized to launch is easier? What sort of steps need to be taken in order for an international collaboration to happen?
Well, we have to decide what needs to be done on the international level and what is best done on the national level. So, the U.S., Luxembourg, maybe some other states soon will have passed laws or will pass laws dealing with the use of resources in space.
Yeah.
U.S. government creating a law that says U.S. entities, citizens, and corporations can own and possess asteroid resources. So that's an action on a national level. Luxembourg also has done that action, saying it is capable for Luxembourgish companies to appropriate and use and own and trade in and sell asteroid resources. Again, action on the national level. Some people said, no, that needs to be an international discussion with a new treaty. But creating a new treaty for that type of activity may take 10 years or longer. That's how long treaties sometimes take to negotiate, to go through all the work and processes of that. So in the meantime, would that stifle activity? So, there's strengths and shortcomings of having new international law, new treaties. There's strengths and shortcomings of having new national law. It's going to be up to people in all the stakeholders for space to say, let this activity, say it's satellite servicing, can be mostly regulated on the national level. But we're going to have some type of international safeguards in place to reassure states that may be curious or hesitant or suspicious of that type of activity and may think that it's not merely for peaceful commercial purposes, and they may suspect that it's actually for security military purposes. But it's going to be on a case-by-case basis for, say, satellite servicing has different geopolitical repercussions than space debris removal, and again for manufacturing space, for use of space resources, for commercial space stations, etc.
Interesting. There's another question from the chat room from Tawicked that asks, in your opinion, should the United Nations create their own orbital tracking projects so that there would be unbiased open data to all members so that hopefully situations like what you just described could be avoided?
The thing about the United Nations is they can only do what member states ask them to do and also give them money to do. And that's the goal of it. And so you can ask them to do something, but until you actually also fund that program and assist them in standing it up, they won't be able to do it. So I think that something like that, the UN international approach, it could take quite a long time. And I don't know. Hold on. Can you show that question again?
Yeah.
Let me think about it a little bit more.
Tawicked asks, should the United Nations create their own orbital tracking project, like TDRIS, or I forgot what the Russian one's called, so they could have an unbiased open data to all members?
I mean,
I really like that idea. I think that would be great, because let's say, for example, if someone said, oh, hey, the Russians just launched Cosmos 5437 and we think it's some sort of interceptor, United Nations comes out and they're just like, actually, according to our orbital tracking data, it's in this particular orbit, it's not rendezvousing to anything else, it's this particular size and shape, and it's transmitting these signals, so it's this type of satellite, not this type of satellite. Like, would that be feasible?
Some type of like unbiased referee or commentator that can say, we know for certain. I don't know. I mean, the U.S. doesn't really, or the UN doesn't really have that specific role in other domains. They don't do that type of activity for like the oceans
tracking
or airspace. It's done on a national level. And then, like the space situational awareness, SSA, it's space traffic management, STM, they're very difficult and probabilistic. You can't exactly tell where a space object is. You have basically a cloud of probability for where it, like a zone that could be many kilometers across for where you mostly predict it is. I don't know. And beyond that, I don't have a strong yes or no opinion on that. Maybe it's possible.
Interesting. Well, kind of going back to funding for a moment, where does Secure World Foundation get your funding from?
Oh, so NGOs usually have a number of private donors. We have one private donor that stands up the foundation that also has, the family also has other NGOs that deal with like piracy on the oceans. So part of, we have one NGO that is focused on peaceful and sustainable uses of outer space. One is on, oceans and the use of the oceans and preventing piracy on the oceans. And, that's essentially what NGOs try and get up to and do roles that governments are and no one else is doing. And they usually come from like private backing.
Interesting. Okay. That makes sense. I do have two kind of random questions. This first one comes from Minnie Stoge, who is our own Lisa Stojanowski, and she asks, is the Kármán line recognized in space law?
No, it is not. But that doesn't mean it's not an important line. So for folks who don't know, Theodore von Kármán, is that Theodore? Came up with, an idea of where space should begin based on where air gets so thin that above that, essentially, wings of aircraft don't have any lift. And above that, you'd need to put something in orbit. The technology would be different. And I think it was originally set at, was it 100 kilometers?
I believe so, yeah.
But he also admitted, and this is, just something done within I think it was the IAF in the 1950s. He admitted that as technology develops, that line may move around. So if you really want to get into, I know that one of the world's most renowned experts in space and space technology, Jonathan McDowell, published a paper updating that perspective on the von Kármán line and where he would set the lower boundary of outer space. So you can find more. Just Google Jonathan McDowell, and you can find stuff from that. And I think his paper is open access.
Awesome.
Looking at where to draw a line. I think he draws it slightly lower, but it has no legal repercussions or merit behind where you draw that line.
Sure. And I think the United States Air Force, I know they used to, I don't know if they still do, but I think they had their line at like 80 kilometers or something like that. And then depending on who you ask, they're like, well, it's as soon as the atmosphere stops, but there's still a tenuous atmosphere, thousands of kilometers up. So it gets confusing there, but thank you for answering that. I have two more questions from you. This next one comes from our chat room from Dutta, who is our producer, who asks, are other countries as sensitive or suspicious as we, the United States, seem to be about what other states are launching?
Some are.
Some are.
You have to have your own verification system. You have to have eyes that are looking to space. And eyes in space to see what's in the space environment. And I think, but no matter what, you have to, states are encouraged by international space law to register their space objects with the UN Registry of Space Objects that you can find on the USA website. Objects launched into outer space. It's done pursuant to the 1975 Registration Convention. And also UNGA Resolution 1721A. So you're supposed to register your space objects. And that's really just a transparency measure to say, well, this is what we've launched into outer space. In addition to that, you have to coordinate your frequencies with the ITU. That's not a transparency measure solely. That's also so that you can use that frequency and you don't interfere with other uses of that frequency, and who else is going to be using that frequency. So there, essentially can't really hide what you have in space for very long. People will find out about it, and if you don't coordinate the frequency, you will suffer frequency interference. Interesting.
Okay. So I hope that answers your question. Now I want to ask you a really important personal question. And this is something that we try to ask everyone, and I'll just throw it right out there. Why space? Why are you doing this? And what excites you the most about space right now?
Oh, okay. How much time do you have?
Take as much time as you want.
What's that?
Take as much time as you want. Why space?
Okay. So I went to law school in New York. I was not, and I went to Michigan State University. I got a degree in literature with philosophy and sociology. I was not in any way science or engineering or STEM minded whatsoever. I was, definitely social sciences, literature, and philosophy minded. But I hung out with people that watched Star Trek, and I watched Cosmos in my high school physics class. It was awesome and amazing. But I never connected it with anything that I would want to do, or that I aspired to do. But then once I started working in the legal field, and I did, commercial litigation, trial preparation, and stuff in New York City near Wall Street. I took a night class in international law, and in that international law class, they discussed maritime law, and another chapter discussed aviation and space law. And I remember reading that while my day job was in the financial services industry and the legal industry, totally the other end of the spectrum. It had no relation to outer space whatsoever. And I was just shocked and blown away by the fact that there was something called space law, that there was an outer space treaty, and that there was an astronaut agreement and a moon treaty. And it just seemed so surreal, science fiction-y, almost slightly unbelievable that these things, existed, and that people took it seriously, and that it was a branch of international law, and that we have lawyers that do space activities. So I went to a few conferences. I came down to Washington, D.C. and went to a conference that happens every December, the Galloway event, and met people that work as space lawyers, and was blown away that these people could exist, and that's their living. They're serious adults, and that's their job. I'm a space lawyer. And so because of that, I think I want to get into this. I think that this is, so why space is that, it's looking towards the future. It's premised on, people that work in the space industry are always thinking about, this launch is coming up soon. Next year, we're going to do this. Next year, the spacecraft is going to get to this planet and observe this planet. It's looking towards the future, visions of the future, planning for the future. It's explorational, and it's not looking backwards all the time like many other fields do. So because of that, that was intriguing to me, and I like that aspect of it, that it's forward-looking. I also like the aspect of it that it's something that is, you're taking part in a greater endeavor. You're not taking part in something that is solely for yourself and your own profit, that there's a global space industry, a global space conversation, a global space endeavor that pushes forward what humankind can do. So when imagine we will have the technology to perform satellite servicing, or manufacturing in space, or use of resources in space, or, asteroid threat detection and mitigation and response. These are like civilizational milestones that, that are just astounding and humbling, that you could take part in something that now you're part of a species and a civilization that can do these things. Don't you want to be part of an industry that is achieving these hitherto undreamed of milestones?
Yeah.
That's unlike other areas of professions that you could work in. That type of pushing civilization forward doesn't happen if you work in tax law, for example, or if you work in property law, or many other areas of law that could be fulfilling, could be profitable, that serve a purpose. But for me, I have that type of anxiety that I want to know that what I'm doing has a greater purpose besides myself, and that it's something that is fulfilling. Even if I have a very minuscule, infinitesimally small role in pushing things forward, it's fulfilling to know that you're taking part in pushing something forward.
Wow. That's awesome. Great answer. That's exactly what I'm all about. Thank you so much. We definitely have to have you come on the show again. There's so many exciting things to talk about, and so many questions that we didn't even get to. So definitely have to have you come on again sometime. But thank you again so much for joining us and for answering our questions today. Now, before we get going, yes, thank you. You are welcome to stick around, by the way, if you want to in After Dark. Otherwise, you're good to go for here. But for the rest of you who are watching, please stick around, and we are going to have a comments and questions from you, the community, that we are going to address. But before we get into that, I want to give a huge shout out to all of the patrons who are supporting TMRO. These are our escape velocity citizens who are contributing $10 per episode, and you guys are really making the show happen. I am just so blown away by your guys' generosity and your support. But we also have our orbital citizens who are contributing $5 per episode. And you guys are, oh my gosh, you guys are really making the show happen. And I, again, just thank you so much to each and every one of you for your guys' support. It really means a lot. But if you would like to contribute to the show and help us out, don't forget to subscribe and hit the bell so that you're notified anytime we have a new video. Share this video with your friends. And if you would like to support the show, you can head on over to patreon.com/TMRO to help us do even more cool stuff. So stay tuned. We'll be right back to talk about your questions and comments.
Science. It both draws us together and tears us apart, brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
And thanks for sticking around. Now we're going to get into your questions and comments from you, the community of tomorrow. Now, if you weren't here last week, we had an amazing roundtable that was consisted of Tim Dodd, the everyday astronaut, Anne-Marie Stagmer, Nicole Stott, and Neve Shaw. And we were talking about the Dear Moon project and how amazing that was and inspiring for all of humanity to go and explore the moon together. And our first comment for today actually comes off of YouTube, and it's related to last week's show. It's from Hanafi Din. And they say, well, scientists couldn't draw or paint or have that appreciation of nature to save their lives.
Well, I don't know about y'all, but
yeah, go. What do you think?
yeah, no, absolutely. I feel like we were all just vibing on the same wavelength so hard. I didn't know if I should just say it, but I mean, was this, I couldn't tell, first of all, is this sarcasm or were they?
No, this seemed legit to me.
Oh, okay,
there was a comment thread that started in YouTube, and like people were like, "What are you talking about? Scientists don't know." And this person was like, "Well, you know, they don't. Scientists are trained to be analytical and to communicate in a certain way that is good for communicating data to other scientists, but not necessarily communicating that
in an
data to
way.
the wider world, which is why science communicators exist, right?"
Well, okay, I can agree with that, but that doesn't necessarily mean that scientists can't draw or can't create pieces
express
of art.
themselves creatively. I mean,
Yeah.
look at Einstein. He was a huge piano and violin fan and player. In fact, if he wasn't a scientist, he says it, himself. He would have been a musician had he not taken up science. Yeah. And then even Richard Feynman was a very dedicated painter. Mm-hmm. So to say that, I mean, I think it's kind of an insult to the scientists to say, well, they couldn't do that to save their lives. And
even just talking about space, I mean, astronauts. We had both Alexei Leonov from Russia and Alan Bean from the United States creating incredible pieces of art.
How could you not be inspired after seeing that? Exactly.
Yeah.
And so, I think it's a little unfair to say either, artists don't have the capacity to be scientifically minded, or scientists don't have the capacity to have an aesthetic appreciation or a creative kind of outlet like that.
Yeah, every scientist I've ever met or interviewed or worked with, I would ask them, if you weren't a scientist, what else would you do? Every single answer has always been like a polar opposite of what science really is. So every single person I've met, it was either they want to do musical theater or they want to be a musician, and and it's weird because a lot of us might know that with music and music theory, it really goes hand in hand with mathematics. So there's so much intertwining happening between science and math anyway. Sorry, science and art anyway. Whether or not maybe they're not aware of it, but yeah, most scientists they have like a whole other passion that they do and career.
So we have a great summary of all of that in the chat room. Aspen says, people are multi-dimensional.
Thank you.
Yes.
People are human.
Yes.
All right.
We have layers.
So that
Like
actually leads
onions.
in really, really well into our next comment. So from YouTube, Evan Smith says, I personally don't agree with that A joining the letters of STEM, science, technology, engineering, and mathematics, A standing for art. There is a reason STEM is separate from other disciplines, and although there could be important existential meaning in the art that would be inspired and produced during a lunar orbit, these products will have varied meaning to everyone and little to no utility in furthering the much more challenging art of spaceflight. Ready, go.
Once again, I disagree.
I'm gonna call it ironic. He called it the art of spaceflight.
Right? Oh, there it is. We need say no more. Yes, we do. Go on.
I think that art in the context of STEM is really important, and that's where this whole STEAM thing came from. It's not art just for art's sake. It's art for the purpose of expressing science, technology, engineering, and math. Yeah.
Exactly. And not only that, but I mean, art for art's sake is important in and of itself, but it's not just the production of art, it's the creative thinking that comes along with it.
Yeah.
So, I mean, I like that they do mention how is this relevant to the challenging art of spaceflight. I mean, this is all about design thinking. This is about engineering. I mean, the innovations that are going to take us to places beyond what we can imagine is going to require thinking, I mean, I hate to use this cliche, but outside the darn box, you know what I mean?
Yeah.
So you need that. You need STEAM, you don't need just S or E or A or M or T. You need them all together. The future is interdisciplinary. So.
Exactly. I actually love what Loopy Dragon says. STEAM is Carl Sagan's Cosmos.
Heck yeah.
And it's just like, yeah, it's, I mean, even like the movie Contact as well, too. Like, well, the book first and the movie. But yeah, I think that it's just exactly what you said. You know, it's also about trying to relay that information that's gathered through science into an artistic form. Because it's also about trying to reach the broader public, you know, everybody in the world, not just the science community. But even then, too, is, yeah, a lot of science stemmed from creativity, philosophy. I mean, astronomy stemmed from philosophy, and philosophy came from creative thinking. And, you know, all of that, it's a constant evolution. So just because we know something now doesn't mean that we can't rediscover something or discover something later on. And a lot of times that comes from thinking out of the box, which a lot of times is out of the box of science. So since everyone isn't scientifically or technologically literate, Exactly.
sometimes that whatever piece of art that does express that is what inspires people. Like in my head, I'm sitting here thinking about this whole Dear Moon project, and what if there's some really inspiring pieces of art that makes Congress go, oh, space is awesome, let's double NASA's budget.
Let's double the budget.
Exactly.
Yeah.
I mean, you never know if that it could take that one congressperson just being so absolutely awe-inspired, and then kind of taking that back to their constituents, and then just there's so many benefits to making art accessible, making STEM accessible to, you know, society on a general scale. And I mean, yeah, if you want to get things done, you have to make it impactful to Congress. You have to make it impactful to the people who have effect on policy.
The voters, too. Yeah.
I was just going to mention, I agree mostly with what you guys are saying, but also if A should be related to the rest of the letters in STEAM, then why in universities and such are they so segregated? Why do you have, you know, a college of science and whatever, and then you have a college of arts and humanities, and they're not together?
Good point. I think, I mean, well, traditionally, I mean, if you are going into one field or the other as your focus, then yeah, there should still be like not an exclusivity, but there should be like a pretty, I think, prominent focus on one thing. But I think that as you kind of get a little bit further into your academic career, that's when it starts marrying. So say you're like an engineer and you are working in a fab lab. I mean, that fab lab, theoretically should have, you know, artists and designers should have access to that fab lab as well, because then you have...
Wait, what's a fab lab?
Oh, sorry, fabrication lab. Like, so for instance, like with 3D printers, laser cutters, things
like a makerspace.
A makerspace, precisely. And so, I mean, even in like high schools and colleges, they're experimenting with this, giving access to students from basically any department. I mean, so long as they're, you know, adequately trained by the staff, and having them minds kind of come together. So while maybe it's not in the curriculum itself yet,
it's the future of education.
Exactly. The application, therefore, is more synergistic.
Awesome.
Yeah.
All right. Let's switch over to a little bit of a more technical question. This one comes off of our community forums from Sean Devine. And they ask, does anyone know what is used to insulate the super chilled fuel storage tanks? This is in relation to SpaceX. I'm from the area near Boca Chica Beach, and I can tell you it is way hotter than Florida or McGregor. As of today, McGregor, Texas is 82 Fahrenheit, 28 Celsius, while Brownsville is 32 Celsius, 91 Fahrenheit.
So the fuel storage tanks, we're not talking about the tanks on the rocket itself, we're talking about the tanks at the launch pad. I have no idea what the insulation's used.
Vacuum jacketed insulation.
Vacuum jacketed insulation, thanks to Dutta. Thank you very much for that.
So, I mean,
Google food
does
is
it
strong.
does it matter? Does it matter that Brownsville is so much hotter than McGregor, Texas? As a human, we perceive that as hot, but is it really that much of a difference, you know, to the fuel that is already at this really low temperature? Like,
As long as you have the proper insulation.
It will increase the boil off, and then in doing so, increase the pressure in the tanks, and all that needs to be managed.
If the temperature rises and gets above a certain point.
Yeah, blame that on the day job.
awesome.
Okay.
Cool.
Wow.
Well, here you go. Community, your questions are answered here.
We give you what you want.
Okay, so next week we have a really cool guest coming on. But before I tell you who that is, we're going to do this really amazing thank you to all of our guests. Not guests, patrons.
Our patrons.
Patrons! You're amazing patrons, I love you! Escape Velocity patrons contribute $10 or more per episode. Thank you so much. We could not do this show without you. But we also have our Orbital subscribers as well, who contribute $5 or more per episode. Thank you so much. We couldn't do this show without you, and honestly, it just blows my mind that you guys are so invested in the show. But we also have our suborbital citizens who contribute $2.50 per episode, and I'm going to keep talking here so you have time to find your name on the screen. Thank you so much, and we really appreciate what you guys do for us. But we also have our ground support citizens as well, who contribute $1 to $2.49 per episode. And again, thank you. Hopefully I can say thank you enough times that you can find your name on the screen. This list gets so big every week. The font is getting smaller and smaller. Eventually, you know, you're gonna have to have the best eyes in the world to be able to find your name. And we probably should come up with a solution for that. Maybe we need 2 slates, I don't know.
Microfiche.
Maybe.
Anyway, thank you so much. And if you would like to contribute to the shows of tomorrow as well, head on over to patreon.com/TMRO. And honestly, if you can't contribute financially to the show, you can always help us out by sharing with your family, friends, people at work, just anyone that you kind of talk to about space and be like, yeah, you know, these cool things are happening in space. And if they don't know, show them our show. I mean, that's what we're here for. We're here to get people excited about exploring the cosmos.
That's right.
Yes.
But speaking about things that are cool in space, next week, oh my goodness, I'm so excited for this next guest. Next week, we have ALE, or Astro Live Experiences. We're going to be talking to Josh Rodenbaugh from ALE, and they actually do on-demand shooting stars. We're going to be talking about how we can all experience a meteor shower together wherever we are on the planet with on-demand meteor showers.
That sounds dangerous.
That's pretty epic.
I mean, maybe it is
sound really
dangerous. I
epic.
guess we'll
It's just
find
little
out.
speckles of maybe just like salt bay.
salt
Maybe
guy.
shooting star bay. Like there you go.
That still sounds dangerous.
Oh my goodness.
That still sounds dangerous. Oh man. So you're gonna have to check out next week to find out how that works.
It's going to be I'm really excited. And next week, dun dun dun, we have a doubleheader with Tomorrow's Science. Do you guys know who we're interviewing on Science? I'm so excited to announce this right now.
Oh my God, who is it, Lisa?
We are going to be talking live with a station in Antarctica inside a greenhouse that is making the future of how we create food on this planet and off this planet.
Amazing.
Oh my God.
Live from Antarctica.
Live from Antarctica.
It's going to be so cool.
Will there be
That's
polar
so
bears?
cool.
There are no polar
so.
bears in Antarctica, but there are penguins.
Will there be penguins?
Maybe. You'll have to watch next week to find out.
So
Science-
excited. Pumped.
Science, you can join us at 2030 UTC next week, and Space will be on at 1800 UTC. But until then, After Dark is up next. We did miss a comment in this week's show. We're going to talk about it in After Dark. But until then, we'll see you next week. See you later. Bye.